Hello everyone, welcome to Headway Civil Online Study. In my earlier video, I explained how to identify zero force members in a truss. In today's video, we will learn about determinate and indeterminate trusses. So, a truss is said to be determinate when it can be analyzed using equations of equilibrium alone. What are these equations of equilibrium? In case of 2D structures, plane structures, there are three conditions of equilibrium which must be satisfied. So what are these conditions of equilibrium? The first one is summation of Fx equals to 0. That means sum of forces along the horizontal direction equals to 0. Summation of Fy equals to 0. That means sum of forces along the vertical direction equals to 0. And summation of Mz equals to 0. That is sum of moments along the z direction equals to 0. For the stability of the 3D structures, there are 6 conditions of equilibrium which must be satisfied. So here we have got 3 conditions of equilibrium and here we have got 6 conditions of equilibrium. Right? What are these conditions of equilibrium in 3D structures? Summation of Fx equals to 0, Fy equals to 0, Fz equals to 0, summation of Mx equals to 0, My equals to 0 and Mz equals to 0. Here you need to remember how many available equations of equilibrium are there. So for 2D, in case of 2D we have got 3, in case of 2D there are 3 and in case of 3D there are 6 available equations of equilibrium. Now what we understand by indeterminate truss? So a truss is considered statically indeterminate when the static equations of equilibrium are not sufficient to find the reactions or unknowns on that structure. First note one thing. For example, if I give you an equation like x plus y equals to 2 and I ask you to find out x and y, will you be able to find it out? The answer is no. Why is it so? Because we have got here two unknowns x and y, but the available equation is only one. So in order to find both of these unknowns, we need at least two equations of equilibrium. Now if I give you another equation like x say minus y is equals to 4 and I ask you to find out x and y values now you will be easily be able to determine these values. So to find out two unknowns, we need to have two equations. That means the number of unknowns and the number of available equations has to be same in order to identify those unknowns. So in determinate trusses, number of unknowns and the number of available equations are same. Whereas in case of indeterminate truss, the number of unknowns are more, or we can say are greater than the number of available equations. That is why we cannot identify all the unknowns using these equations that is available in 2D. We already saw there are 3 available equations of equilibrium, and in case of 3D we have got 6 available equations of equilibrium. Now what are these unknown reactions? These unknown reactions depends upon the support conditions. So for first one, that is fixed, which we generally note it like this, fixed support, there are 3 unknown reactions in 2D and in 3D there are 6 unknown reactions. Right? So in 2D there are 3. That means it is restrained from movement along the horizontal direction, it is restrained from movement around vertical direction, and also it is restrained against rotation. So rotation is also 0. For hinge support, which we generally note hinge support as somehow like this, there are 2 unknown reactions in 2D and there are 3 unknown reactions in 3D. Hinge in 2Ds, they are restrained from movement in along the horizontal as well as vertical reaction. If we look at one hinge support, it will have one vertical reaction and one horizontal reaction, whereas in case of fixed support it will have horizontal, vertical and also a moment. That means it is restrained from all the 3 directions. The reactions is actually whose movements are restrained, right? In case of hinge, we have got 2. And in case of roller, which is generally indicated by somehow like this, in 2D we have got 1, and in also 3D we have got 1 restraints. So if we draw these figures, there is only vertical forces present. So here it's vertical. In fixed we have got horizontal as well as moment, and here we will have vertical and horizontal. So to analyze these indeterminate trusses, additional compatibility conditions are required. So the total static indeterminacy is actually the sum of two things. One is the external static indeterminacy and the other is the internal static indeterminacy. Okay, what do you understand by external static indeterminacy? See, here it's written that it's equal to the number of independent external reactions in excess. What do you mean by that? When we have got extra number of reactions than the available equations, we consider the structure as externally indeterminate or externally redundant. That is, we know in case of 2D, the available equations are 3. That means if my reaction forces are greater than 3, so here it's already written, you can see DAC, that is the external static indeterminacy, is equals to RE minus 3, where RE is the number of external reactions. These external reactions which we already saw, that in case of fixed for 2D it is 3, hinge it's 2 and roller it's 1 in case of 2D, and in case of 3D it is 6 for fixed, 3 for hinged and 1 for roller. Right, now what do you mean by internal static indeterminacy, or we can say as internal redundancy? It refers to the geometric stability of the structures when members are extra. Note this thing. In the earlier case, we had reactions, extra reactions. Here we'll have extra members. Then we can say the truss or the structure as internally indeterminate or internally redundant. The equations by which we can make it out is DSI must be equals to m minus 2j minus 3 in bracket. In some of the books, you will find out these equations written somehow like this. It may also be written like m minus 2j plus 3. Okay, so this is big. If you remove this bracket, it becomes plus 3. If I ask you dsi as equals to 0, that means if I say dsi as equals to 0, what it will become? It will become like m minus 2j minus 3 equals to 0, or we can write m equals to 2j minus 3. At this point, we consider the truss as internally determinate. Because it's determinate, why? Because you'll be able to find out the number of members using 2j minus 3, which will come. Now if m becomes greater than 2j minus 3, it will be internally redundant. So if we sum these two things up, the external redundancy and internal redundancy, we will get the total degree of static indeterminacy, which is given by the formula these two. We need to remember these two formulas to solve the problems. The first is ds equals to m plus re minus 2j, where m is the number of members, re is the number of external reactions, and j is the number of joints. And ds equals to m plus re minus 3j in case of 3D trusses. In case of 2D trusses, it will be equals to m plus re minus 2j. Right? From here also we can make out if ds becomes equals to 0, we can say the truss is stable or statically determinate. ds, if it's greater than 0, we consider the truss as statically indeterminate, or we can say as over stiff. And if it's less than 0, we consider the truss as unstable or deficient. So these three portions has to be remembered, because you will find questions coming from here. Here are a few examples I've shown you. Let us look and solve these problems. In the figure that is given, You can see there are in total how many members there are present. We'll count the members first. This is 1, this is 2, this is 3, this is 4, 5, 6 and 7. So the number of members is 7. Number of joints that is present. Number 1 joint is this, number 1, this is number 2, this is 3, this is 4 and this is 5. So the number of joints are 5. Now let us look at the number of reaction forces or external reactions. Since this is a hinge support, this is hinge and this is a roller support, and we have been written here that's a plane frame, pin jointed plane frame. That means a plane truss, right? So it's 2D. We know for hinge there will be 2 reaction forces and for roller there will be 1 reaction forces. The total external reactions will be 2 plus 1, which is 3. So to determine the static indeterminacy, what is the equation that we need to apply is ds is equals to m plus re minus 2j. So let us write the equation first. So we'll write ds is equals to m plus re minus of 2j. Now substitute the values. M is 7, re is 3 minus 2 into 5. This is coming out to be 0. So we can say it's a perfect truss, or we can say it's a determinate truss, and is stable. Because we know that when ds is equals to 0, the truss is stable and statically determinate, and also we can consider the truss as perfect truss. Next, let us look at the next question. So in number 2, this figure, let us look at the number of members there present. So here the number of members are 1. Since this is not a joint, it's been written here, members not connected here. So this will be another member 2, this is another member 3, this is 4, this is 5 and this is 6. So total we have 6 members, and the number of joints here is like we have got 1 joint, 2 joint, 3 and 4. So total joints we have is 4. Look at the number of external reaction forces. Since it's a hinge, there will be 2 reaction forces. This is a roller, there will be 1. We are considering a plane figure, right? So the total number of reaction forces will be 2 plus 1. Often people gets confused about this force. Remember, this is not a reaction force, okay? Only the reaction forces are those which are coming from the support reactions. Those are the reaction forces or the external reactions, okay? Next again, we will be using the formula m plus re minus of 2j. What we get is 6 plus 3 minus 2 into 4. Substitute the values. 6, 7, 8, 9 minus 8. So it will come out to be 1. That means it has the degree of indeterminacy 1. 1 degree of indeterminacy. If the value would have been 2, we would have said 2 degree of indeterminacy or 3 degree of indeterminacy, this way. So we can say that this truss is indeterminate but stable. Right? Next, move on to the question 3. Here the truss is given. Similarly, we will find out the number of members, we'll be looking at the number of joints, and we'll be looking at the number of reaction forces. This problem I'm leaving up to you. Just find out the value of ds and tell me what will be the conditions among these 3. Whether it will be stable or determinate, it will be stable, indeterminate, or it will be an unstable truss. Thank you everyone for watching. Do like, comment, subscribe and share my videos for more updates.